Welcome to Solar Energy, Seasons, and the Atmosphere. This lecture represents the very first lecture in the Atmosphere section of the course. This is going to continue for a couple of weeks. By the end of it, we'll be talking about climate and what makes the climate regions of the world. But we're going to start off talking about the sun, the atmosphere, and seasons, and then talk about heating and circulation before we move into water, weather, and climate issues. On a very basic level, to start off with, the Earth's atmosphere and the Earth itself is heated primarily by solar energy. Solar energy is energy that comes from the sun, which we will also refer to in this class as shortwave radiation or insolation. And do remember those terms in case I use them at other places. Every body in the universe gives off energy. The energy that's given off by the sun, its temperature, is largely in the spectrum of ultraviolet light, visible light, and what's called near infrared, as can be seen on the graph on this page. Energy that is given off by the Earth, which is much cooler than the sun, is largely infrared energy, which we will refer to as long-wave radiation or thermal and Earth energy. And it's very important to understand the distinction between these two. The energy that comes into the atmosphere is a different form of energy than the kind that ends up being trapped inside the atmosphere, something we'll be talking more about later on. But before we do that, we need to talk a little bit about how the energy that gets to the Earth is distributed in different ways. On a very basic level, the energy that strikes the Earth near the equator is much higher quality than the energy that strikes near the polar areas. And this is because the Earth is a curved surface, it's a sphere, and the energy that is striking in the polar areas, both the North Pole and the South Pole, is much more diffuse, as this diagram shows. The much more direct insolation that strikes the equatorial areas is much more intense and brings much greater heating. In addition to this, as we all know as hardy Alaskans, there is a solar distribution of energy that is seasonal as well. In the wintertime, we don't get very much solar energy. Days are short and the sun is low on the horizon. During the summertime, the sun gets high and it's up for a long time as well. Now this needs to be explained. We need to be able to understand why there is this seasonal distribution of energy. And it has to do with a number of things which can all be explained by understanding how the Earth moves around the sun. On a very basic level, the sun shining on the Earth illuminates one half of it. This is called the circle of illumination. The Earth rotates on its axis through that circle of illumination once a day, every 24 hours, giving us day, or when we're in the shaded, non-illuminated side, night. Of course, at the same time, the Earth is revolving around the sun. And as it does this, its axis is tilted. But the tilt of the Earth's axis is always in the same place in the heavens, pointed towards the North Star. And because of this axial parallelism, as the Earth moves around the sun, revolving around it on what's called the plane of the ecliptic, different parts of the Earth are more or less illuminated at different times of the year. Here's a diagram that shows, number one, the Earth rotating on its axis and revolving around the sun. But here you can see the Earth is tilted at an angle of 23.5 degrees. It's on that plane of the ecliptic as it is moving around the sun, but it's always pointed to the same place. So as we can see on this diagram right here, only on March 21st and September 22nd, what are called the equinoxes, is that circle of illumination bisecting both the North and the South Pole. That's the day that day and night is equal everywhere on the planet. But if we take a look at December 21st over here, which is the winter solstice, when the northern hemisphere of the planet is tilted as far away as it possibly can be from the sun, as the Earth rotates on its axis through that circle of illumination, the sun doesn't get as high, and a lot more of the planet in the northern hemisphere is cast in shade. That's just the opposite in the southern hemisphere, where it's winter. December 21st is the winter solstice in the southern hemisphere. The summer solstice in the northern hemisphere is around June 21st. And here you can see how the northern hemisphere, in fact, any place that is north of the Arctic Circle, is cast in 24 hours of daylight. And we get a lot more sun here, and the sun is also a lot higher compared to the winter equinox, when everything north of the Arctic Circle was in darkness. And they have long periods of darkness. In fact, the North Pole has half a year of darkness during the winter time and half a year of sunlight here. The sun is most directly overhead on June 21st on what's called the Tropic of Cancer, most directly overhead in the southern hemisphere on the Tropic of Capricorn over here. It might take you a little bit of time to study this diagram, but try to get an understanding of it so that you have a clear sense of how seasons are created, and how the solstices, equinox, tropics, poles, and equator, as I mentioned, are a part of that seasonality and help us to understand it. With respect to any individual place on the planet, and here is some northern location, let's imagine, you'll see that on June 21st, the sun gets very directly overhead compared to what happens in the winter. And in Alaska, these suns are all a little bit farther down than what we see right here. But you'll see that the sun rises not at the east, but a little bit north of the east and north of the west, and it provides extra daylight because of that. During the winter time, the sun gets much lower in the horizon, and it doesn't rise at east, to the south of east and to the south of west, so the days are shorter as well. This refers to the altitude of the sun at its zenith and the azimuth of where it is rising. And the reason why in Alaska our very short days provide very cool temperatures is directly a result of the fact that we just don't get very good quality light, and it's very short as well. In the summertime, things warm up. Our quality of light isn't as good as it is in a tropical area, but we get a lot of it over the course of an entire day. These are the basic principles that help us to understand the heating of the planet on a seasonal basis. Now, before we move on from this lecture, it's worth noting that what is being heated is, of course, the atmosphere. The atmosphere are the gases that are held to the planet by gravity. They're composed mostly of nitrogen and oxygen, but there are other important gases as well, including water vapor and carbon dioxide, which we'll be talking about more later on. Many of these gases are so-called greenhouse gases, which are really good at absorbing that long-wave radiation that comes from the planet. And that's one of the reasons why the atmosphere heats so effectively when it does. All of the gases being held to the Earth by gravity are essentially exerting pressure on the surface of the Earth, and this is what is known as atmospheric pressure. As we go higher and higher in the atmosphere, that atmospheric pressure decreases, as this diagram shows right here. Throughout the lower part of the atmosphere, and the part of the atmosphere that we will be entirely dealing with in this class, called the troposphere, the temperatures decrease as we go higher because there's less atmosphere to heat. There's a slight increase that takes place in the stratosphere because of a special kind of gas called ozone, but we're not going to be spending a lot of time talking about that in this class. We will be focused on the troposphere and the boundary between the troposphere and the stratosphere called the tropopause. Last item here is just a chart that shows the basic composition of the atmosphere. Be familiar with that, but don't worry about me asking you numbers and percentages and things like that. I tend to ask questions on exam that are much more generalized than this, looking for broader understanding rather than detailed information. So that's all in our early introduction to solar energy, seasons, and the atmosphere. We're going to move on from this, talking about the heating of the planet.